Le même que ta mère. I said same to your mom. Same to your mom's.
Non, je l'ai pas. Je sais pas.
Same comme ta mère. Ta mère ne supporte pas ma bite parce qu'il est très gros.
Oui.
Your mom can't handle it because it's too big.
If you wanted to know what is the gradient, what is the gradient? So, now the problem we have is that it's changing. The slope is changing. It's continually changing. And how can we find what that slope is? Now, we could, by our eye, try to draw a tangent which lines up with the slope of that point. Draw a point a line which just lines up at that point with the slope, so it just touches once. However, what we're going to do is look at a way where we can actually calculate that. Because drawing the tangent by eye, we might not get the exact answer. It's very hard to be precise. However, we can, using the maths we've developed and the maths we're going to develop, actually calculate what the answer is. It's going to use that idea of limits, and it's going to use that idea of gradient that we saw last week. Hopefully seen it before, but reminding you about gradient. Okay, so here's the idea. First of all, let's choose 2 points. Big idea. Actually, let me just say, before big idea, let's say big problem. Let's say we've got a big problem. Gradient change. Sorry about that. Big idea. So step 1. Choose a second point. So let us choose x equals 5. Now, if we draw the straight line between them, it's not actually going to be parallel to the curve. I mean, my parabola here is a bit wonky, as we said. But the idea, if we drew a straight line between them, then it's not the slope of the curve at 3, but it's an approximation to it. We can see, well, it's the right sort of angle, it's just not precise. So that's our first step. First we're going to choose a point and calculate what the gradient is, and then we're going to do make it get closer and closer. That is the big idea. So choose a point equals x, equals x equals 5, calculate gradient. And then we do repeat or closer. Okay, and you'll see what I mean, that we could do a series of closer and closer points, but what we'll actually want to do is say, well, let's use a bit of algebra. We'll put a bit of algebra in the mix, and then we can work out what value it would be getting closer and closer to. So we're going to calculate the gradient for 2 points. We'll do a couple of examples of that, but we'll say, what about if we made those points get closer and closer together, what would the value approach? And that will be the value we're after. So let us just do that then. Let's do it with x equals 5. Has anyone got any questions at this point? No. Okay, well let's do it and we'll get there. So this is the big idea which underpins differentiation. So let us try that. Okay. So at x equals 3, y equals x squared is 9. We have a special symbol for that. We write it with a triangle, delta y, delta y. Have you come across the term delta y already in any other modules for a small change in y? No. Okay, you probably will. So the increase in y, delta y, what was the increase in y? Well, it's 25 minus
What's that?
9.
What?
Delta.
So that is 60. And the increase in x, which we write as delta x.
So why is he writing delta underneath? Well, we don't know what delta is the sign, you know?
Okay, well that was
the
5
change in that.
minus 3, which equals 2. So, gradient is delta y over delta x is 60 over 2, which is equal to 8. So we've taken 2 points on the curve and we've worked out what's the change in y, what's the change in x, and we've in effect drawn a line between them. And so the gradient of the line joining those 2 points then is delta y divided by delta x, and in this case we can see it's 8. However, the point x equals 5, or point at given with x equals 5, it isn't that close to x equals 3, so looking at the graph, we're expecting this might be slightly big, okay? If you look at how it changes, this slope of the red line is actually steeper than we'd expect if we drew a tangent. So let's try x equals 4, see what will happen there. So if you do try the bar, let me just note what I just said as well, but x equals 5, not that close. So what we're going to do is try x equals 4. Okay? So we do the same thing, we say at x equals 4, y is equal to x squared, which is equal to 60. X equals 5, y is equal to x squared, which is 25. So delta y, change in y is 25 minus 60, which is 9. Delta x, oh, I made a mistake there. Ah, sorry. Okay, yeah, so that should be 3. Okay, let's try that again. Okay, so we were supposed to be doing 4 and 3 rather than 5 and 3. I apologise, so that should be 9. The change in y then is from 16 down to 9. Correct that. 16 down to 9, which is 7. And the change in x is 4 minus 3, which is 1. So the gradient delta y over delta x, which is 7 over 1, which is 7. Okay, so as we expected, when we move the points slightly closer together, the value of the slope dropped.
It doesn't suit my complicated.
Okay, now we could go on doing this. We could say, well, what about if they were half? What about if they were 0.1 apart? What about if they were 0.01 apart? And we could try and spot what it was tending to. However, by using algebra, we can
Tilts on this way.
do it in a bit more of a convincing way.
When you come out,
Let
you
us
go down the
use
hole.
some algebra. What about? Okay.
Do the proof.
Right, what about? Okay.
I wonder
Something
if this was
curious
cold
here.
and
We're going to say it's at 3
a
plus
bit nipply
8.
on.
Okay, x is 3 plus 8. So if we put h equals 1, we should get the value we just calculated 7, because 3 plus 1 would be 4. If we chose 2, we get 3 plus 2, which would be 5, which should give us this value 8. But we're going to say, because all we're going to be able to do is calculate what should the answer be given the value of h, and then we're going to let h get smaller and smaller and smaller, and say, if h tended to 0, what would the answer be? So this is the basis of our big trick. Okay, let us do that again. So at x equals 3 plus 8. Okay, now when we introduced functions, we said, we did examples exactly like this. If you, even though we don't know what h is, we know what the output would be, because it's just going to be the square of it. So y is equal to x squared, which is 3 plus h all squared. Now, we need to multiply out the brackets there, and if we did that, we would get 9, we get plus 6h, plus 8 squared. I'm just going to write check. You need to go outside of this, just check you're happy multiplying out 9 plus 8 all squared, so that's right, 3 plus 8 times 3 plus 8, that should give us 9 plus 6h plus h squared. Okay. Now you may be saying, I hate algebra, why is it introduced selection? It's because it will help us. It will help us see what the answer is going to be. Okay? So, anyone got any questions about that? So this is starting now to sort of pick up the pace. We're starting to do strange, weird, wonderful things, but it will help us.
But I want to know is why you square if we can work it like that.
Okay, let us complete this then. So, x is equal to 3. Okay, so has anyone got any questions about that? Okay, so if you haven't got questions, if you can just then keep it quiet so people who are desperately trying to hold it in their head and see what's going on, they can do that. But do, I say, if you have got questions, do ask them, because I'm sure other people have got questions as well. So any questions? Okay? Okay, so thinking point 3 plus 8 and 3. So in this case we will get y equals x squared, which is equal to 9. Okay, we can do the same calculation. The change in the value of y is going to be 9 plus 6h plus h squared. That was what we got there. And the difference between the two values is 6h plus h squared. Okay, changing the value of x, well we have 3 plus h and 3, so this is equal to h. Okay, so what is the gradient then? Gradient is equal to delta y over delta x, which is 6h plus h squared divided by 8. Which is...
He could just do a quadratic
Okay.
equation.
I was going to say, which is 6
I don't
plus
know
8.
if it's shit or...
Let me carry on and then I will say at the end. So that gives us 6 plus h. Okay, and then we'd say, well, what happens to this gradient as h gets smaller and smaller and smaller and tends to 0? As we make those 2 points get closer and closer to 0. What would happen? Well, this h here will fade away, disappear, and leave us with 6. So the answer is 6. So as h tends to 0, the limit of, let's say, delta y over delta x as h tends to 0 is 6. Okay? So that is the gradient. That is the gradient of the line at 3. We've done something pretty impressive, pretty magic. The Greeks didn't manage to do this, and it wasn't until Newton and Leibniz about 1600 that they managed to
Shout out, bro.
1600. Okay, one final point then.
Oh.
This symbol here, this is a bit of a thing to write. Instead of writing that, we write dydx.
Little reminder.